Hi, everyone. Good morning, afternoon, or evening, I guess, from where you're joining. We still have a few people, looks like they're logging in, so we're going to give them just a minute to get settled before we go ahead and start. But while we're waiting, I'll go ahead and just go over a little bit of housekeeping. Today's webinar is being recorded, so you'll get an email, I think a couple hours after the webinar with a link to the recording. So don't worry if you missed something or really want to see one part again, you'll have that, or be able to share with colleagues if they weren't able to attend. We also are going to open up the floor to questions at the end, but if you have them throughout the webinar, you can go ahead and use the questions feature to go ahead and send something in, and I'll hold them and pose them to our presenter at the end. And by the way, I'm Jacqueline Garcia, our education manager over at Synergex. Forgot to introduce myself. Obviously not the person you're seeing on screen right now. But let me see. You are muted currently, though, and we'll allow you to unmute yourself at the end to do some Q&A as well. So I think that's about it for housekeeping. Welcome. Looks like a couple more people were able to join us during that. So welcome to our third webinar in this series, Harnessing the Power of Harmony Core Web Services. If you weren't able to attend previous sessions or haven't been able to catch up, that's okay. You're still in a good place to be here with us today. And we do have recordings of those previous sessions that you can catch later if you'd like to catch up. Today's presenter, as I mentioned in previous sessions, was a longtime member of our consulting staff, and he's recently transitioned into a product manager role. He's also the product owner of our Harmony Core open source product. So welcome, Steve Ives. You can see him on the screen. We're also joined by our Harmony Core technical lead and a principal engineer here at Synergex to help field some questions at the end. So welcome back, Jeff Green. On the line. So at this time, I guess, Steve, go ahead and take it away.
Okay, thank you. All right, folks. So we left off at the end of the last webinar, if you're with us, and if not, you can review it on YouTube. Having created from scratch a basic Harmony Core web service, that web service had the ability to do things. Sorry, I'm just trying to get my head around what things are on what monitors here. Had the ability to do things like retrieve information about, this is a collection of all customers, for example. We had the ability to drill in and look at things by primary key, so we could retrieve a single customer or a single order or a single entity. We had count endpoints so that we could say, well, how many customers are there, and have it tell us there are 38 in this case. We'd exposed things via alternate key, so we could perhaps look at all the customers in a certain zip code area. So that's what we're looking at here with this query. We had also enabled the ODATA query syntax, so we could use URL keywords like select and filter and order by and top and expand, so that we could perhaps look at customers in descending order of credit limit, perhaps, which is what this report is, or what this query is here. We'd also looked at enabling the use of relations between entities, and if you remember, one of the queries, that's a large amount of data, that's why the browser took a little amount of time to render it, gave us the ability to query through a complex OData URL, basically joining files. So this is that one where we had the little slight technical glitch last time. It's been addressed, as you can see if you know what you're looking for. So here we're looking at customer number 8 and the first order for customer 8 and the first item for that order and the inventory that supports that and the vendor that provided that inventory. That's where we had the little glitch last time. And we're joining all of these 5 files together and selecting and ordering and filtering data as we want to use in our application at this particular point in time. We'd also enabled create, update, and delete, but because of time constraints, we didn't demo that. So that's pretty much the entry point. Also, bear in mind, we'd also shown you that each service, when we're generating this stuff, as well as the service being self-describing by exposing its service document, and the service being self-describing by exposing formal OData metadata that's consumable by other tools to cause other things to happen, excuse me, or integrate with this service. We also, by default now, we've made a decision in the last couple of weeks that we're actually just going to turn this stuff on, period. In the last webinar, it was actually an option that we turned on. Now, by default, we're producing API documentation in all cases. And that API documentation shows you all the endpoints that are exposed by a service based on the type, so customers, items, orders, and so on. You can drill into all the various endpoints. It's actually interactive, so you can go try it out, enter customer number 3, execute, and there's the data for customer number 3. So the API documentation that gets produced automatically now. Without having to turn any options on or off. So that's basically where we left our service. What we're going to do today is we'll leave the service running, and I'm just going to hop back into a new utility that we haven't seen before. We mentioned this briefly, but in order to test anything that's sort of create, update, delete, anything that's not a simple GET request, and in REST, create, update, delete uses operations in HTTP like put and patch and post and delete. Then you can't easily simulate those things in a simple web browser. You have to use a piece of software or write some code. A piece of software to construct a post request or a put request and so on. And that's what we're looking at here. The primary one that a lot of people use, it's not the only one, there are others. But one of the best ones, I think, is something called Postman, and that's what we're looking at here. So let's look at an example of what Postman can help us do. Postman has workspaces. So I'm in a workspace called Harmony Core Demo. If I go to Steve's main workspace, we'll find out that there's all kinds of stuff already defined over here. But I'm going to go into this little blank workspace. Over here, we have something called collections. Collections, I think of as being collections of things related to a specific API. So I think of them like as a master folder for this service, and you'll see how that comes into play in a moment. And within collections, you have folders and requests, and you'll see all this stuff in action. One of the things that we also code generate, it was an option that we did enable way back in the day. If I go off to Solution Explorer and look at our code generation. Don't know why I'm looking over there. This image is also in front of me. If I look at the code generation script, one of the options that we did enable right back at the beginning was, if we can find it here, there's my mouse. There we go. Enable Postman tests, and we haven't looked at what that does yet. But essentially what that does is when we're generating all of your controllers with all of the endpoints, essentially based on the various options that you've specified in this file. So, whether you want get all and get one and create, update, delete, post, put, patch, and so on endpoints, we take that information and we selectively create what's called a Postman export file. So if we go to Postman, we can import that. We simply hit the import button. We go to upload files. We go to our solution directory, which in my case is, where did I leave it? This one. And you should find a file called postmantests.postmancollection.json. And if you import that file, you'll find that it imports information into Postman. So here we can see we've now got a Harmony Core sample API folder. And within there, we've got basically our 5 main data entities, our structures, our files, if you like. And within there, we've got various tests for all of the operations. So reading all customers, counting customers, reading a single customer. There's the alternate key stuff, and doing a put, a patch, and a delete, which we haven't demoed yet. Create, update, and delete. So we can use Postman to demonstrate those things, and that's basically what I'm going to do right now. But bear in mind, everything you can do in a browser, you don't have to switch between the two. In fact, most devs probably just probably rarely test things in a browser. They probably much more often, probably exclusively, once they've learned about a tool like this, even for GET operations, it's simpler to test in here. If we execute our read all customers, then there's the data. It gets nicely formatted, not based on do I have a browser plugin, but based on the fact that Postman does it. I can also selectively say, well, I'd like to see the data raw, or I'd like to go into preview mode. So it has these different ways of viewing the data. Postman also exposes not only the URL and the results, but it nicely exposes all of the other related information. So this tab set here, this main tab set is multiple requests. So if I have other requests going on, like read all customers, read a customer, I can have tabs up here. So within each request, there are two main areas. There's this there's the URL, and notice this is a GET request versus these are all the other HTTP type requests or verbs. And then below there are two tab sets. This tab set represents the request to the server, and this tab set represents the response from the server. Okay, so if I close this one down and then open it up from scratch, you'll see we don't have a response tab set yet. We're set up to do a GET to that URL. Notice also this server-based URL. That's using what's called a Postman collection variable. So if you right-click on the collection itself, you'll find that the collection is not just a simple folder, it has properties. So if we look at the collection, one of the things we can do in here is we can specify variables. So for example, I've got a variable called server-based URI, and by default, it contains the URI to the base of the service. So what this allows me to do is if I take this service and deploy it to an IIS server or change the URL in some way, then I can just come in here and edit the base address one time, and all of my individual 62, in this case, request tests all pick up on that change because it was specified once. So that's what this orange server-based URI is doing. Here's the request. We can see that we've got maybe authorization information. We'll see that come into play later in this demo. We can also see the request headers that are being sent out. Not quite sure why that's there for a GET request. That's probably an error in our template, actually. But if you've ever worked with HTTP, you'll know that there are certain headers that get sent to a server to say, what is the content type of the data? What is the content? What is the length of the data that I'm sending? Oh, sorry, accept. Sorry, I'm thinking content type. So accept is saying I'm doing a GET request and I would like the response to be in JSON, please. So some services might be configured to be able to return XML data or Atom data or some other format. In this case, that would be the default anyway, but I'm just being cautious and specifying and saying I would like JSON data. And there are various other headers that tend to get sent to the server, some of which are sent automatically by Postman. There's also a body of the request. Now, this being a GET request, there is no body, but if it was a put or a post request or a patch request, then there would be a body that gets sent, and you'll see that later, and so on. So there's all these attributes of the request, and then we go ahead and issue the request, and we now get a response tab set where we can see the body in the various forms. So this is the data that actually came back from the service. We can see it in its various forms. We can also look at any cookies that may have come back from the service. There aren't any in this case. We can look at any HTTP response headers that came back from the service, and so on. And also notice, this is very important here, notice there's a little summary of the HTTP status. So it says 200 OK. That basically tells me this was a successful request. To anything is a success status. 4 anything is a fail status. 5 anything is basically a failure, a failure in the service, an actual failure. The 400s are failures like not found and not allowed and stuff like that. It also tells you how long the request took. So it took 61 milliseconds to receive all of these customers. And it tells us the size of the data that came back, which was 13.95K. So this is all very useful information to a web services client developer and a service developer. It's good to know how your service is responding. So we can use this for all of our simple GET requests. Bear in mind that when we do generate these Postman tests, we do, if we're dealing with key values, we simply place an arbitrary value. We use 1, 2, 3 if it's a numeric field, and we use ABC if it's an alphanumeric field. So what you will have to do is, if you want to read a customer, if I try 1, 2, 3, I'm going to get a 404 not found because I've only got 38 customers in my database and that isn't one of them. But if I want to retrieve customer number 17, then I would have to change the primary key value and do a send. And there you can see is customer 17. This test has now been marked as dirty because of the orange blob. So I can, if I want, save. I just did a Control S there, and that will now have been remembered for this particular test. So you don't have to configure that every time if you remember to save. So the point of this was, as well as doing simple GET requests with Postman, you can also use it to demonstrate, create, update, and delete. And that's what we're going to do right now. So as I mentioned, I think briefly last time, there are two different ways of creating something in Harmony Core services and in REST services generally. There you have a choice between, and generally this is a choice on the service. It will be one way or the other based on the requirements of the application and its logic. And this is all to do with basically how the primary keys get decided upon in the first place. So there are two real scenarios. Either it's left to the developer to say, I'm creating something and this is the primary key, or the client essentially, or the client posts something without a primary key and that primary key is generated and assigned in the back end, like what's the next order number kind of thing. So typically it'll be one or the other. And we haven't got, well, in our world, we do a post if the key is being allocated automatically, and we have to have some plumbing, some custom code to make that happen, to say, where does the key come from? We're going to do that next after this quick demo of what you get for free. And if you want to do if you're specifying the primary key value, you do a put. And a put is what's called an upsert. It will create an entity if it's not, if it doesn't exist, and it will update or replace the entity if it does exist. So put can be used for both create when you are specifying the key and update. And a post is always a create where you don't get to specify the key. So I'm going to demonstrate all of these things. We haven't got post switched on yet. Way back at the beginning of the previous webinar, if you remember, when we configured our code generation environment by looking at our regeneration batch file, I believe we turned on, where is it? There. We turned on put and patch and delete, but we did not turn on post yet. So we'll come back to that and do that later. Okay, so let's flip back to Postman. What we'll do first of all then is show you how to create a customer when you get to specify the primary key value. So that's a put operation. So I'm going to click on create or update customer. You'll see that we're doing an HTTP put. Our URL is our primary key endpoint. So we're targeting a specific customer that we want to create, and we're specifying the customer number. Now, I know that we'll let it just use 123. That's fine. That does not already exist. We do have some HTTP headers in play. So we've got, let me hide the automatic ones. We're specifying a content type of application JSON. Postman, we also, if you're sending data to an HTTP server, generally you have to use content type and content length. Content length will be calculated by Postman and will be provided for us. So if we look at the hidden headers, you'll see that content length is calculated when request is sent. So it's doing that for us. There are various other headers that you almost always have to send when you're communicating with a web server of any kind. One of them is host, for example. What is the name of the host you're communicating with? And again, Postman's dealing with that for us automatically. So we have to specify that we're sending JSON data, and then in the body of the request, there's the data that we're going to send. Now, you'll notice I've got, again, this data was just randomly generated. Actually, this data is based on sample data that's in my repository. There's a special little token you can put in the long description for every field that says sample data is, and that's what this will use, and that's what we're seeing here. So there's a discrepancy between my primary key that I'm asking it to create and the customer number. The logic in the service says that the URL always wins. So either I should, if I'm doing this, I should probably make sure it's the same. But really, I don't have to provide a customer number in the body because we are providing the customer number in the URL, and that's the one that will win. So probably should do a little bit more work on the code generation of the tests and make sure that's not in there. But it's no big deal. The code in the service literally overwrites that one with this one at runtime. So there we go. We're ready. We're set up to do our thing. Let's just go back to read all customers and just prove that if we do a read all and we go to the end of the list, the highest customer number on file there, you can see is 38. So if I try and retrieve customer number, I'm sorry, I'm clicking on the wrong monitors again. If I try and retrieve customer number 123 and do a read of it right now, we will get a 404 not found. And then if we go to our create or update with our put and do a send, we get a, oh, okay, it's requiring it to be there. I apologize, something changed. All right, let's just leave that customer number in there. See, it said 404 bad request, telling me the data's bad, and it told me customer number must be between 1 and 9999. That's because we've got some required field validation going on, and it didn't get suppressed in this particular scenario. So let's do another send. Let's send our request. And now we're getting, there you go, 201 created. So whenever, according to the rules or the guidelines of REST, whenever you create a new entity, two things should happen. Three things should happen, actually. One, the response should be 201 created, which is a specific, I created a new entity. Two is the complete data for the new entity should be returned to the client, and that's what you're seeing here. Notice the customer number is 123. And the third thing is you're supposed to send a response header. So if we look in response headers, you'll find a header called location, and that basically gives you the URL that can be used to retrieve that new entity. Okay, the reason there's a slight difference here, and the URL here says customer number equals 123, and this one just says 123. In ODATA, you can go for primary keys only. You can go either way. For primary keys, you don't necessarily have to name the key segments, although it's probably considered good practice to do so. But both of these scenarios will work. So again, if we now go back to our read customer for 123 and do a send, now we get a 200 OK. So it's been created. I also mentioned that a put can be used to update an existing entity. Well, now it does exist. So we could also go back to our put and we could change something. So if I change the street to be, I don't know, instead of 1032 Main Street, let's be 123 Main Street. And then we'll do another send. Now we get a different response. We get a 204 no content. Okay, 204 is a success status. It's like a 200 OK, but it's telling us no content. It's telling you, OK, but I'm not sending you any data. And that is the appropriate response for an update. You don't need us to tell you what the whole of the data is for the new entity, because a put, when an entity exists, is a complete replace. So all we're telling you is we took the entire piece of data you sent us and we stored the whole thing to the database. So it was a successful operation. Again, if we go back to our read a single customer and do our send, we should see there that the address changed to the value that we specified. So there's create through put, there's update through put. And of course, we can do the well, let's actually, before we do a delete, let's do the next thing in the list, which is you can patch data. So a patch is an instruction to do a partial update. So we're updating customer 123 with a patch operation. And with a patch, what you do is you send a request body that is a little JSON document that is instructions for things to change. So for example, it's saying operation is replace, property name is street, and the new value for street is going to be 456 Main Street. Okay, so we were 123 Main Street. And you can send multiple operations if you want. Notice this is a JSON array. So if I want to, I can come in here and say, put a comma in there, and then say also replace state with California. I think it was, what was it before? We were in Missouri before, so now we're going to be Springfield, California. I think, isn't California one of the states that doesn't have a Springfield? Anyway, so here's our patching. Sorry, where are we? Well, here's our patch instructions. We're saying don't replace the whole entity, just apply these changes to the current entity. So all that's going to get updated is street and state. And if we do our send, then we get, again, a 204 no content telling us I did what you asked me to. So that's a successful operation. And again, if we read the customer now, we should see the street and the state have both changed. So that's a patch doing a selected update on one or more properties within the entity. And finally, we have delete support. So if we go to our delete, you will see that we've got still server-based URI. We're still targeting the specific endpoint with the specific customer number. We are not sending any particular headers. We're telling us if there's a response, we'd like JSON, but there isn't going to be a response from a delete. We're not sending anything in the body. This is kind of like a simple GET request. The only difference really is you're doing a delete instead of a GET. And we're simply saying to the server, just delete this entity. So we do a send and we get a 204 no content. Again, 204 being a success, but there is no return value or no return body. And that tells us this entity has gone. If we try and do the same thing again, then of course oops, mouse is on the wrong monitor again. Then again, this time we're going to get a 404 not found because we've already deleted it. And now we try to do it again. Notice how fast this stuff's happening, by the way, 35 milliseconds. It fluctuates up and down a little bit as you do with multiple times. Look, 24, that one got a little bit faster. Pretty cool. Okay, so that's create, update, delete. Let me just do a quick sanity check. Now what I want to do is show you what you have to do if you want to support post. So post is what is basically saying we want to allocate primary keys on the back end. Okay, so let's look at how we do that. How are we going to do that? We're going to go to Visual Studio. Mouse, where are you? Okay, there. We're going to go to Visual Studio. We're going to stop the service from running. We're going to add some code. Now, I'm going to just be rather blasé and just drop this code in. The reason is that this is all documented. If you go to the Harmony Core Wiki and you look for, there's a couple of topics. One is adding a primary key factory and another is adding create operations. It's all documented. All the code I'm going to use is documented on that website. So I'm going to fly through this fairly quickly and just show you what the overall process is. So to do a create, we have to do two things. We have to, first of all, well, several things. We have to provide what's called a primary key factory class. So Harmony Core has plumbing that lets it say, oh, we're doing a post. We need to get a primary key, call this thing in this interface, and we have to provide an implementation of that. And the way where that goes is we need to drop some new code into our services project. And I happen to have that code on this monitor. So if I drop that in there, you'll see that what I added was something called primary key generator. And again, this code is all in the wiki exactly as it appears here. In fact, it builds it up step by step in the wiki and explains what's happening. But long story short, what this code is doing, we have a relative file called sysparams.ddf. We're bringing in the record layout from the repository. And essentially what we're doing here is Harmony Core is telling us, what do you need a new primary key for? I need a new primary key for customers. And this code basically reads the next available primary key from one of the records in the relative file, increments that value, uses it, records that it's been incremented, and so on. So it just literally gets the next value from a relative file based on what type of record are we trying to create. Now, that might be similar to your implementation, or it might be not similar. You might do it a completely different way. It doesn't matter. This mechanism is still the same. You just have to provide in here, based on what file it is, what structure it is, you need to have some code that comes up with the next primary key, however you do it. You just might be able to plug in an X call here and just call something, or you talk to your data or whatever. So that's basically what the code in this class does. So that's basically all the code in this class does. Okay. The next thing we need some custom code in our environment to tell Harmony Core about our primary key factory class. So that is, again, we do customization through a couple of mechanisms, one of which is through partial classes. So you'll notice we've got a startup class here. This is where, wrong monitor again. This is where all of the initialization and configuration of the whole Harmony Core environment happens. And this startup class, two things. Notice it is defined as a partial class, so we can extend the content of it. And within the partial class, we use several partial methods like configure services custom and so on. So you can add a partial class with a partial method, and if we see it at runtime, we'll call it. I'm not going to go into more detail about that. If you don't know what partial classes and partial methods are, again, go to the wiki documentation for Harmony Core. There's a little bit more of an explanation there for what is actually going on. But all I'm going to do for the time being is I'm going to grab a partial class, I'm going to drop it in, and you'll notice this says Startup Custom. So this is a second part of the Startup class. It has an implementation for the Configure Services Custom, and it has two things in here. This code, in our environment, as I explained last week, we have code that creates all the data files. Every time you run the service, it creates a fresh set of data files, and then it deletes them at the end. And that way, that every time we run our demo environment, we know we've got 38 customers and X number of orders, and this is the next available. It's always the same, okay? So what this piece of code is doing is copying in a copy of the relative file so that the next available order numbers are always the same. And then this piece of code is recording the instance of our primary key generator as a service in our dependency injection environment, so that basically we're plugging in and telling Harmony Core, here is a primary key generator for you to use. Okay, so those are the two things we have to do. And again, this is all documented in a tutorial, so you can walk through this process yourself and do it line by line. Okay, the next thing we're going to do is edit our regeneration environment. So let's go back to our solution environments regen, and let's go find that bit that we didn't turn on last time, which is the enable post. Okay, and I'm going to save that, and then I'm going to go to again, I'm losing control of my mouse tools, Command Prompt X64. Like we did last time, I'm going to go up into my root directory, my solution directory, and I'm going to regenerate our code. And I believe I had this stuff all checked in before we started. So if we go to, you won't be able to see this because it's behind my head, but if we go to Team Explorer and we look at the changes, you should find that here's the new changes we just made to the services project with the new files. Have been added to the project, and we've got some changes to our controller classes now. And the changes to the controller class, surprise, surprise, is a new endpoint method post. Okay, and that's so we've added code into our controller methods. Okay, that should be all we have to do. So if let's do a build, make sure everything's working okay. So all we really did was plug in a key factory, and that enables us to turn on post. If you were to enable post without having a primary key factory, things are just going to fall over at runtime when you try and do post operations. So the two really need to go together. Okay. Right. So it built successfully. Let's run up the service. Let's just press F5, run up the service. Of course, it always starts on the wrong monitor, so let's put that over there. And so there's our service running. So now we should be able to do a post operation, as well as, oh, by the way, as well as generating new entities into the controllers, we also generated new content into the Postman tests file. So you'll notice we don't have any post operations here. But if I re-import the file, now unfortunately this is going to overwrite any custom parameter values I may have put in there in the past. There's not much I can do about that right now. So I'm going to say replace. So I've just replaced all of my Postman tests, and now we've got 5 additional ones. So as well as put, patch, delete, we've also got a post endpoint for each customer or for each type. And you'll notice here that, again, in the headers for the request, we are sending content type application JSON. We're saying we are sending you JSON data. Here is the data we are sending. In this case, I can take out the customer number because I'm really not supposed to provide one. If I do, it's not the end of the world. Again, we will overwrite it with the provided value. And I think in this case, we have got the code in there that lets us do that. So let's just verify that. This may fall apart and do exactly what it did last time, but I don't think so. So we're going to create our new customer record. We know, again, if we review, because we just restarted, okay. Yeah, now my mouse has completely simply stopped working. Bear with me a second. There we go. Strange, it had new batteries yesterday, but the red light is flashing at me. Okay. Where was I? Okay. If we go, we've reloaded the data. So in theory, if I do if we do a read, let's do a read all customers again. First request always takes a couple of seconds longer to the service. Again, highest customer number is currently customer number 38. So now if we go off and do our post, let's just select, there's the post that we had, and let's do a send. And again, we get a 201 created. Again, you can see the response there. But notice that the primary key value in the return data has been set to 39. So that's the value that came from the relative file that said this is the next available customer number. And in fact, if I do this operation again, the next one is 40, the next one's 41, the next one's 42, and so on. So we're allocating primary keys on the back end, and notice we're not providing a primary key in the data. We're not providing a primary key in the URL. So a post operation, a put, you address a single entity, a specific entity. A post, you simply address the collection of entities, customers, orders, items, and the primary key is allocated. Okay, and again, if we go back to our read all customers, well, let's just do a count customers, then we should find, yep, now we've got 42 customers in play. So that's how we do a post. By the way, of course, as well as adding the entries to the controllers and adding the new items to the Postman test files, we also code-generated new, well, actually, we don't code-generate the documentation now, but the documentation will now include somewhere, there you go. So there's the post endpoint for each type. And it tells you the possible return values and so on. So this is telling us we could get a 200 success or a 400 bad request if we send bad data. Okay, so everything gets updated along the way. Okay, that is it for demonstrating a post. Now what we're going to do is we've got 20 minutes left. This should work out about right, hopefully. We're going to move on to the subject of customer authentication. And it's okay having this service, but I don't want the world to be able to get to it. I need some kind of concept of login. Now, this is a real complex area. We're just going to address the basics in this scenario. We're going to protect the entire service, and we're going to require an initial username, password, exchange and validation. In response, what we're going to do is have the server return something called a JSON web token. That is a secure, cryptographically secure way of proving certain things, that in this case, proving that we have logged in and proving who you are, your identity, your username is essentially baked into the JSON web token. So it proves to the service that you have logged in. The concept is we go to a specific unprotected endpoint, we provide a username and a password. We don't need to worry about security there because we're using HTTPS, so everything's encrypted to that endpoint, as is the whole service. The server processes it, validates it however it does, returns a JSON web token that says, cryptographically secure way, yes, you have validated and you are Steve. And we then send that token back to every subsequent request, and it's validated by the server. And those JSON web tokens, again, I'm not going to go into a huge amount of detail. There is more explanation on the wiki, mainly just links out to jwt.org, which is the JSON web token's primary website. So if you want to learn about how this stuff works, you can also bake additional claims into there, which are permissions that user may have to do certain things and access certain types of endpoints. Yes, we have some support for that. No, I don't have time to go into it today. So we're just going to look at the basics. So that's what we're going to be doing. Basically, what we're going to do is we have an option in our regen file that if we turn these options on, everything gets protected. Okay, so let's basically see that happen first of all. So what we're going to do is go to Visual Studio. Our service is running right now, so let's stop it. And we're going to turn on, I'm going to turn on two additional options. I'm going to turn on Enable Authentication. So an authentication is what you would turn on if you were going to do this stuff, we're going to do custom authentication, which I think for most Synergy apps will be appropriate. And that is saying, I'm going to control the login process. I've already got user and password information in my environment, in my application. I'm going to validate it, and I'm going to issue the JSON Web Token. You can also, if you just turn on authentication, what we do is we put the scaffolding in place for actually using an actual authentication server, an OAuth 2 server, perhaps something like Identity Server 4, perhaps something like Microsoft Active Directory with ADFS, or it could be Azure AD. All of these things do OAuth authentication and will return JSON Web Tokens. So with authentication plugged on, we're configuring things. There are some key bits of information elsewhere that you have to provide. You have to tell it certain pieces of information to tell it who to trust. Where do these tokens come from? That's what that environment is about. But if I also turn on enable custom authentication, it tweaks things a little bit. So now we're going to be generating the JWTs in the environment. Okay. By the way, if you've got an older project, you will not find these options doing the same thing. What I'm about to show you now has been implemented in the last 2 weeks or so. So if you want to do this sort of stuff, I'd strongly recommend you get your projects up to date with the latest templates, latest version of Harmony Core, latest code gen, and then all of this stuff just gets generated for you. If you're not aware, we do have now a command line project update tool. So updating to the new version of Harmony Core is a fairly simple thing to do now. You go to your project, you download a new tool from NuGet, you run a command, and it updates all of your NuGet package references. It updates all of your templates and all of your traditional bridge files and so on. And it works pretty well. Again, look for upgrading the Harmony Core solution in the wiki, and you'll find some information about how to do that. Call us if you've got any problems, or get in touch with us if you've got any problems. So I'm going to turn on both, and that basically means we're going to do the authentication ourselves. I saved the changes. I'm going to go down to my window that I apparently closed. So, oh no, is it over here? It's over here. I apologize. I probably didn't show you the last time I regenerated the code. It was on the wrong monitor. Okay, so I saved it. I'm going to regenerate the code again. You didn't see this last time, but there's us rerunning our code generation. And what we've done now is we've made several changes. We've added some new source files, and we've made some changes in the startup code and so on. So quite a lot just happened. Essentially, what we did was we've added 3 brand new source files to start with. Let's get those into the project. They've been generated straight into the project. One of them, if we go to Solution Explorer, is in the models folder. You will find that we've got a new class, an existing item called Authentication Models. And all that's in there is a little model, a class called getTokenRequest, and it has 2 properties, username and password. So this defines the data that we're going to require the client to send to us to our authentication endpoint in order to obtain a token. So if you're all 3 of these new files that have been generated have been code generated in a way that they will be created the first time only, but will not be replaced when you regenerate code. So if your login mechanism requires a branch code or some other kind of information, then go ahead and add a property or properties here. So this is basically, what do you need the client to send to you in order to correctly authenticate who they are and whether they have access. So you might need them to send you a branch code that which branch are you trying to log into or something like that. The second thing we've added is 2 things into the controllers project. So again, wrong monitor. Let's go off to our controllers project, and we're going to again add existing item. And we're going to add, we've got authentication controller and authentication tools. And you'll see how these things work in a moment. Authentication controller is, as its name suggests, a web service controller that is available at the URL path authentication. And there is an operation called getToken, which is a post operation because we require the data in that data we just looked at a moment ago has to be posted in the body of the HTTP request so that it's encrypted. And basically, here is where we do the validation. So I've just got it hard-coded right now. I'm looking at the request and saying, is username, okay, and is password, and I'm requiring password to be lowercase, okay. I'm uppercasing the username, so username in any case, password must be in lowercase. So that's my login credentials. Clearly, you might make a call into some piece of back-end code, or you could write some custom code, or call a traditional bridge method if that needs to happen on VMS or Unix or something. Whatever you need to do to say, here's the credentials, is it valid or not? And if it is valid, then I'm using this authentication tools get token to get me a JWT based on this username, and I'm telling it how long I want the token to be valid. Again, remember, this code is not replaced when you regenerate code. So the intention is you can edit this code to your heart's content to make it do. And you might want to move some of this logic into helper classes and things like that. Whatever you need to do, this is just intended to be a simple working example. In authentication tools get token, very briefly, I'm not going to walk through it in detail because I'm getting a little, well, actually, I'm not getting short on time. We're doing okay. If we jump into that with an F12 go to definition, essentially, here's the get token method. It takes the username, it takes the duration. I'm not going to walk through this code in detail, but this code is basically using the cryptography stuff in the .NET Core framework and some other stuff to create a JWT. Here is where we're creating the token itself. Here we're adding a claim, so we're embedding something called token, which is actually just the username. So the client, when this gets sent back to the client or to the service on subsequent requests, the service can delve into the token and say, what's the username and what's the... So if you had, what branches is this user allowed to access, you could have a valid branches, which is an array of branch numbers, and add that as a claim. Or if you had a what's their default branch number, you could add that in as a claim, and that information would be passed around the system in the JWT. So whatever information you want to propagate. Now, don't put secret information in here. JWTs are cryptographically secure, but they are decodable by anybody. Okay, so you don't put passwords in here. You don't put anything that's secret in here. Because anybody can look at them if they get hold of them. But you just put the context, the state essentially in here of who this user is and what their rights are, perhaps within your service. Here, we've got some expiration time. I'm actually passing an expiration time in from the controller. It's defaulting to 24 hours. But you can change this logic to however you want. JWTs have an expiry time. You might want them to be valid for a month. You might want them to be valid for an hour. But essentially, once it expires, the client is going to get an error, and they're going to have to represent the credentials to obtain a new JSON Web Token to carry on using the service. So that's just something a client would have to take into account when they're dealing with a protected service like this. Okay, so that's basically the code. What we also did was so the authentication controller is the exception, okay? Every other controller that was code generated, if we look at, for example, customers controller, again, wrong mouse, we'll see that we have added, amongst other things, every controller is now decorated with this authorize attribute. And what that tells Web API is that in order to access anything in this controller, you must present a valid JSON Web Token. It doesn't say anything about roles or rules or claims. This is one way of doing it. We're taking a sledgehammer approach and saying, you have to at least give me a valid JWT to access anything. Now, it might be that we apply different things on different operations based on you need to be a manager to do this, and we have some capabilities like that. We don't have time to get into that today. So this is basically just saying you have to give me a JWT that's valid and has not expired in order to access this entire controller. And all of the controllers are the same. The only one that is unprotected is authentication controller, get token, and you can see get token is specifically just in case is decorated with allow anonymous. Okay. Even though there's no authorized, it's just we're double covering it here. So this one can be accessed by anybody in order to get a token if you have an appropriate username and password. Okay. So that's the concept of how this stuff works. I believe that's all we have to explain. Let's see in action. So in theory, if we go and let's build our service, just it would do that if I just ran it anyway. I guess I could have done that. Let's take this opportunity to have a little coffee. Okay, and come on. Okay, so our service has built. Let's run our service. Again, it's starting off screen, so let's bring that over here. And our service is now running. So what we should find is that everything is protected. Okay, so if I now go and say, well, how many customers are there, for example, it's probably going to tell me 401 unauthorized. Say, sorry, you can't do that. Okay, how about can we read customer number 1, please? 401 unauthorized. So basically, I can't do anything at this point. I'm dead. The only endpoint I can access in the whole service at this point is that that get token endpoint. So we better look at how to do that. What I tend to do is, because this collection is going to get overwritten, I tend to probably start with a new collection, and I'll just call this custom stuff. Okay. And in that collection, maybe I create a folder. Let's do that. How do we do that? Add folder. Let's say authentication stuff. And maybe within that folder, I'm going to add a request. That request is going to be authenticate and get JWT. Okay, so let's save that. So here's our request. The URL that we're going to access is, this is not an ODATA controller. So this is not part of the /ODATA/v1 versioned thing. It could be, if I chose to implement the controller a different way, I could put it in that normal scheme and version it. But for now, it's outside of that scheme. And the reason for that is if we look in Visual Studio, you will see that most of my controllers that are code generated inherit from ODATA controller. Okay, so they're part of the whole ODATA space. My authentication controller simply extends from or inherits from controller base. This is just a regular web API controller, so I'm not in the ODATA space here, which is why we're seeing that difference. Let's go back to Postman. Wrong one again. I must get my head around that. So the request that we're going to make is, again, I can't use server-based URI in this case because I don't have, because that includes /ODATA/v1. I could add another one, but let's just type it in locally. Let's just do https:/localhost:8086. Where are we? /authentication/get token. So we're going to address that. We said earlier we have to do a post request because we're sending our data in the body. So if we're sending data, we need to add a header, which is we need our content type header. And we want to set that to application JSON because we're going to be sending JSON data. And then in the body of the request, we need to specify our data. So I need a property called username. Sorry, that should be, I don't very often type raw JSON. Username : and this was not case sensitive if you remember. So username, and we need a property called password, which is case sensitive. So we'll do it that way. In fact, let's do it wrong to start with. So let's put an uppercase W in the middle there just to prove things are working. And there's our JSON message. Now, yes, I could format it if I want and get all weird. It really doesn't matter. Okay, so there's our little JSON username password message. That, remember, what we're doing here is we're matching whatever information is in our model. So we've got authentication models, username and password. That's what we're matching with this JSON. And the reason we're doing that is if we look at authentication controller, you'll see that the parameter, this is a post request, and it's got from body required in a request is a get token request. Okay, that's how all this stuff ties together. Okay, so in theory, if we go back to Postman, that should not work for us because we've given it a bad password. So let's try and see what happens. Oh, service isn't running. Apologize. Let's run the service. Oh, service is running. What did I do? Oh, I've got a typo in my URL. JTTPS. HTTPS. Let's try that instead. Is that better? There we go. Okay, what do we get? 401 unauthorized. Okay, it's telling me, no good. It's not going to tell you why. It's not going to tell you what the problem is. I don't believe. No, there's no response. It's just telling you not authorized. Okay, so I can't do that. But in this case, I'm not authorized because my username password is wrong. Okay, that's my service. That's not because the endpoint is protected. It's because my service explicitly says if you send bad data, send a bad request. So what that means is if I go to Postman and say, let's just send garbage data that is just not valid. Okay. Maybe I shouldn't have. You know what? There's a lesson to be learned here. Don't deviate from your demo scripts. Okay. And the whole thing is now dead. Why did I do that? Okay. Can you just do me a favor and just kind of ignore that I did that for a moment while I figure out what is going on here? There we go. Whoa.
And Steve, just to make you aware, time is running out on the originally scheduled webinar. So while you're...
I'm almost done.
Okay. I was going to say, if anyone wants to start typing in their questions, feel free to now. And if we can't get to them before if you have a hard stop at the end of this, we can email you answers later on. So,
yeah. Anyway, the reason is if validation fails, we actually return specifically an unauthorized response. Okay. I'm going to run the service up again. I'm not going to do the silly stuff this time. There's the service running. Let's give it a correct username and a correct password and do a send. And this time we get back a JSON web token. This is our JSON web token. You'll notice it's in three parts. It has a header, a body, and a signature. If I actually briefly take this thing, just to prove to you what this thing actually is, if we go to a website called jwt.io, no, and we post this data into here, you'll see it gets decoded as this is a JWT that's encrypted with an algorithm HS256, and here's the content of the token, and you can see it's got audience is my API, issuer is my company. That's information that I've generated into the service, and my token is username. That's my user ID. So this is the actual token being decrypted. Okay. So there's our token, and just to prove that this stuff works, if we take that token, what we have to do now is pass that back to every request. So if I want to now do a read customers request, I'm still going to get a 401 unauthorized. I could, on each and every request, go into authorization and specify the token, but Postman has a better way. So if I edit the collection, I can go to authorization and set the authorization as a bearer token, which is what we require. and I can pass our JWT in the bearer token and press update. Now, what that does is it adds an authorization request header to every request. So if we now look at headers and look at the hidden ones, you'll see we're now passing an authorization token, which is our bearer token and our JWT. And that is how we prove our identity to the service. And now we're able to talk to the service again for the next 23 hours and 50-something seconds, because our token is valid for 24 hours in this environment. Okay, that's just and again, all of the endpoints will work because we did that at the token at the collection level. Okay, that is the content that I wanted to go through for this particular webinar. I do apologize, we are a minute over. Are there any questions?
Yeah, so I'm going to go ahead and unmute the line. So now if you'd like to ask a question verbally, you should be able to click on your little red microphone and unmute yourself. And otherwise, there is a questions box that you can type any questions into. And while we're waiting for this, I also wanted to mention that we have another webinar already scheduled 2 weeks from today. And that's when there's a link to register for it in the email that you'll get after this. Also, when the webinar is over, a quick survey is going to launch this time. We're testing out the survey, so if you could go ahead and answer those 2 questions for us, we greatly appreciate it. Let me see. Steve,
So the next webinar is going to be, we're going to be discussing custom code. So we're going to start, we've looked at generating services based on ODATA and based on code generation from the repository. What we're going to start to look at next time is how do I do custom business logic type endpoints. And we'll probably do that a couple of ways. We'll show you how you can just embed custom business logic into controllers in your service. And we'll also start to get into something called traditional bridge. So if you want to start embedding existing Synergy business logic and subroutines that you may already have, perhaps migrating from XF Server Plus, although I'm not sure we're going to get into that as a specific topic next time. At some point in the future we will. But generally the concept of including code in endpoints, be that .NET code or traditional Synergy code, be it on Windows, Unix, VMS, doesn't matter. So that's the plan for next time.
And if you do have a question, you're for some reason not able to unmute your line, I have been having some difficulties with GoToWebinar, so go ahead and chat just to let me know if you're having trouble, and I'll see if I can manually unmute you. But as Steve mentioned, we're gonna have a great session 2 weeks from now, so more opportunities to get your questions answered. We'll just wait.
Because it could be that I did such a good job of explaining everything that nobody has any questions.
It is very, very, very possible that is the case. We could do a test. I could call someone in the audience and say, "Hey, can you unmute your line for a second? Say hello."
Hey, this is Don. Cool. Steve, nice job. The unmute worked.
Thank you.
Yay, cool. Great. Awesome. Thanks, Don, for proving it. That just goes to show, Steve, you did such a great job. No questions. Covered it all.
There you go.
Very timely with the authorization. Thank you. Authentication.
No problem. That's video will be on YouTube in a couple of hours.
Oh, and it looks like we got some things in the question box, but just nice job. No questions.
I don't see the question box, so okay.
Yeah, I can share the answers with you.
Okay, I guess we're good to go. Thanks everybody. Yeah. Hopefully you'll join us next time.
Yeah, thanks so much, everyone.